We present a method for estimated lighting from a single perspective image of an indoor scene. From this single input image, our approach estimates a parametric light that is easy to edit and allows renderings with strong shadows, alongside with a non-parametric texture with high-frequency information necessary for realistic rendering of specular objects. Once estimated, the predictions obtained with our model are interpretable and can easily be modified by an artist or user with a few mouse clicks. Our approach consists of trained networks that work together to accomplish this task. We start with the input image, which is passed to a network that we call light network. It estimates the position, intensity, and size of the strongest light source in the scene, and we convert this parametric prediction to a spherical Gaussian projected in an environment map. In the sequence, the layout of the same RGB image is provided to the layout network. This layout defines the borders between walls, ceiling, and floor, and we get it with an off-the-shelf layout estimator. The network then estimates the layout for the entire scene, which should resemble the layout of the ground truth environment we see on the right, for example. Finally, we have a third network called the textured network, which produces a high-frequency LDR lightning prediction with the strongest light source at the desired place, and with the predicted scene layout. And of utmost importance, both layout and light position can be edited by the user. But what does that mean? It means we can edit the result if it's not as desired. So if we want to predict the light for the image on the left, and the network predicts the light on top left with a given texture, we can simply modify the light position, and the texture will be regenerated with the light at the new position, and the render will reflect the difference, so we can see the shadow coming from a new direction. The user can move freely and have control of the prediction. Here we can see more renderings with our prediction. Notice that the shadow projected by the predicted light, as well as the scene details reflected on the glossy objects, are coherent with the scene around the objects. And again, if the user is not satisfied, it's easy to edit the light and have the desired result. So to conclude, our main contribution is a method that brings controllability without compromising the quality of the render, and which works for glossy and diffuse objects. Thank you.